All right, here are solutions for quiz 2 for Math 111. In this first problem, we're asked to evaluate and simplify this stuff, and then it says make sure you express your answer in radical form. Okay, maybe since we're going to express our answer in radical form, we can just immediately change these into radicals. Raising something to the 1/2 power is the same as taking the square root of that number. So the square root of 32 plus the square root of 18 is tempting to call that the square root of 50, but it's not. You can only add or subtract radicals if you have the exact same thing under the radical. So what we got to do is simplify both of these and hope we end up with the same thing under the radical. One way to do that is to find the prime factorization of those numbers. 32 is 2 times 16. 16 is a perfect square, but in case you didn't see that, I'll continue and find the entire prime factorization. If 32 is 2 to the 5th power, or 2 times 2 times 2 times 2 times 2. 18 is 2 times 9. 9 is a perfect square, but in case you didn't see that, or if you did your tree a little bit differently, I'll finish it up and call it 3 times 3, and say 18 is 2 times 3 times 3. And so now that we have those prime factorizations, I can break the square root of 32 up into the square root of 2 times 2 times 2 times 2 times 2, which I can then split into two radicals. I call them good radical and bad radical. I need pairs of 2's over here on the good radical. So since I have 4, wow, that is not legible. Let's try again. 2 times 2 times 2 times 2. Let's try it a third time. That is equal to 1, 2, 3, 4. And that fifth 2 I got to put under a new radical, the bad radical here. And then with the 18, that 9, that perfect square, that 3 times 3, I can put under the good side. And I'm left with the 2 under the bad side. So this good side, by the way I constructed it, it's a perfect square. This pair of 2's turns into a 2. This pair of 2's turns into a 2. This pair of 3's turns into a 3. And so what I'm left with is 4 root 2 plus 3 root 2. In other words, 7 root 2 is my final answer. In the second one, we're multiplying x to the negative 5/6 power by x to the 1/3 power. So really the important thing to notice here is that we have a common base of x. So what we can do is just add those exponents. That's what our first exponent rule, or what I was calling the first exponent rule. So negative 5/6 plus 1/3 is what will be our new exponent. And to figure out what that's equal to, I don't know, maybe you do it off to the side, kind of flashback adding fractions. You can add fractions when you have a common denominator. So the least common denominator in this case would be 6. To make this a 6, we multiply by 2 over 2. I guess what I'm trying to say is 1/3 is the same as 2/6. But it's a lot easier to add negative 5/6 and 2/6. You get negative 3/6. In other words, negative 1/2. So what I'm saying is that this product is x to the negative 1/2 power. Okay, that's good. If you were asked to express your answer just in exponent form, you'd be done. However, you're not. You're asked to express it in radical form. So I guess what you should do is say this is 1 divided by x to the 1/2 power, and x to the 1/2 power is the same as the square root of x. So now we have our answer in radical form. This is the same as this is the same as this. But we're still not done because we got to make sure we rationalize the denominator. So since we have a square root in the denominator, we don't want to leave that there. So in order to get rid of this square root, we'll multiply by the square root of x divided by the square root of x. This thing that I just multiplied by is just equal to 1. So we're not changing the value at all. But what we are doing is square root of x times square root of x is just equal to x. So what we're left with is our final answer is root x over x. This is preferable to this because this doesn't have any exponent or any radicals in the denominator. So this right here is our final answer. All right, next one. Same basic idea. Figure out what these things are equal to, except now they're saying give the answers in exponent form. Square root of x divided by the cubed root of x. So I think it's, well, lots of different ways you can do these problems. One way to do it would be to first get it into exponent form. The square root of x is x to the 1/2 power. The cubed root of x is x to the 1/3 power. So x to the 1/2 divided by x to the 1/3. We got an exponent rule that says when you have the same base and you're dividing, you just subtract the exponents. So what I get is this is x to the 1/2 minus 1/3. Okay, if you can subtract those fractions, it's good. If not, you kind of go over to the side here and say, well, I need a common denominator. 6 is the least common denominator. So this is 3/6 minus 2/6. In other words, it's 1/6. So what I'm left with is just x to the 1/6. And since it wants the answer in exponent form, I'm all done. I'll leave it just like that. All right, part B. Maybe I'll switch colors so they don't run together as much. The cubed root of something, that's the same as raising that something to the 1/3 power. And what is that something? Well, it's the square root of something. Okay. Something, whoops, to the 1/2 power. And what is that something that's getting square rooted? It's x to the 9th. So one way to tackle this problem is to first convert everything into exponent notation. X to the 9th raised up to the 1/2, raised up to the 1/3, and then apply, what is that, our second exponent rule, which says when you're raising exponents to exponents, you multiply them. 9 times 1/2 times 1/3 is 9/6. Maybe I'll show my work over to the side here. When you're multiplying a number by a fraction, it helps to change that number into a fraction. So 9 is 9/1 times 1/2 times 1/3. And you just multiply straight across. 9 times 1 times 1 is 9. 1 times 2 times 3 is 6. So you get 9/6. However, 9/6 reduces. Right? They're both divisible by 3. So 9/6 is the same as 3/2. So instead of x to the 9/6 power, you could write this as x to the 3/2 power. I think that's good. I think you can leave it just like that. I guess there's another way you could write that. Maybe I'll even, is it worth writing it? Sure, why not? Maybe parenthetically. Or x times x to the 1/2 power. If you want, you could have written it this way. The way you could have gotten here is, well, maybe you can just kind of see it. X to the 1 times x to the 1/2. If you add 1 plus 1/2, you get 1 1/2. In other words, 3/2, which is what we got here. Either way is totally fine. This is what I had in mind, but I just figured I'd write it in case somebody did it that way. They could see that their answer was also correct. All right, speaking of problems that you can do multiple ways, we got some big mess, some big quotient, all raised up to the -2 power. X, Y's, and Z's. Lots of different ways you can do this. For me, I like to first take care of this -2 right here. Some people like to first kind of combine these X's and these Y's and these Z's. Some like to just take care of the negative part of this -2 by flipping everything over. I like to take care of the whole -2. So I have this rule that says when you have a bunch of stuff multiplied together, all raised up to an exponent, you can take that exponent and kind of distribute it to each thing that it's getting multiplied by, or divided by in this case. What I'm trying to say is I can make this x to the -4th to the -2, and then I multiply the -4 and the -2 and get x to the 8th power. Y squared to the -2. 2 times -2 is -4. Z to the -2 times -2. -2 times -2 is +4. X -2 times -2, +4. -3 times -2, +6. 2 times -2, -4. So if I were doing it, I'd do it this way. There's some freedom in how you do things. Now we've gotten rid of these parentheses and this -2 exponent right here. So now I start combining. I got x to the 8th and x to the 4th. So I got x to the 8 minus 4. Y's, I got a y to the -4th on the top minus the y to the 6th that I have on the bottom. And for z's, I got a z to the 4th on the top. And from that, I want to subtract, be careful here, I want to subtract a -4. Subtract -4. It's really tempting to just put -4. It's not. It's minus -4, which is +4. So 8 minus 4 is just 4. -4 It's hard to read my writing, but I think that, yeah, it's definitely a negative. Negative 4 minus 6 is negative 10. And 4 minus negative 4 is the same as 4 plus 4, which is 8. Can you leave it like this? Maybe, I don't know. Eliminate negative exponents. No, you cannot. We don't want to leave this as y to the negative 10th power. We want to write it as x to the 4th, z to the 8th, divided by y to the 10th. This right here would be our final simplified answer. If you got to here, you're getting most of the credit, but since it said don't leave any negative exponents, you don't want to leave this as y to the negative 10th. You want to make it divided by y to the positive 10th. All right, I guess that's good. That's the end of this quiz.